Good morning. Today's topic is projectile motion. You know, when a body is an object or a particle is thrown in the upward direction with some initial velocity, then in general, the object follows a curved path. Okay? Object follows a curved path. That curved path is called the trajectory of the particle or the object. And this type of motion, where the motion of the object is governed only by the action of gravity, is called projectile motion. The special case is when the particle is thrown directly in the upward direction, vertically upward direction, vertical, okay? Then the motion takes place in a horizontal line. It goes straight in the upward direction, then it comes down in the vertically downward direction, following a straight line. And in other cases, when there is an angle with the horizontal, the angle is less than 90 degree. Means the angle is in between 0 and 90 degree. The angle is called angle of projection, you know this. So, when the angle is in between 0 degree and 90 degree, in that case, the path followed by the particle is not a straight line. Instead, it is a curved path. And it was proved by Galileo that the path followed by the particle in such cases is a parabola. This can be proved mathematically. In such analysis, the only force which acts on the particle during the motion is force due to gravity. And there is no other forces. Though we know that the particle moves through the air. The particle is surrounded by air. You know this. And so there should be some resistance of air. But in simple mathematical analysis, this resistance is neglected. Just to simplify the problem, this resistance is neglected. Resistance by air, by the presence of air. This resistance is neglected. Such study is called ballistics, and the trajectory of such cases is called ballistic trajectory. So, now I am going to start the problem, analysis of the problem. Problem is like that, only one force is there, that is force due to gravity. A particle is taken, it is thrown with an initial velocity of u, small u, in the upward direction. The velocity vector makes an angle of theta with the horizontal. This is the horizontal line. This way the particle is thrown. So this angle is theta, which is in between 0 degree and 90 degree. Right? Now, this velocity, initial velocity u, can be resolved into two components. One along the horizontal and another one along the vertical. Okay? So along the horizontal, what will be the component? It is u cos theta. And this component of velocity will be unaffected by g. G means acceleration due to gravity. Because direction of acceleration due to gravity is this one, in the downward direction, and this component is this one, horizontal. So they are perpendicular to each other, so there is no effect of g on the horizontal component. Due to the object's inertia or the inertia of the particle will move along the horizontal line. due to the inertia. But the vertical component is how much? It is u sine theta, right? U sine theta is the vertical component. This vertical component will go on decreasing due to the presence of negative acceleration. Means acceleration is in the downward direction and the particle initially moves in the upward direction. So G is acting in the opposite direction of the motion. So retardation is present. So in course of time, means after some time, the particle will reach to zero velocity. And after that, the particle will start falling in the downward direction. Say this is a parabola. So there is a peak point of the parabola. At that peak point, the velocity, the vertical component of the velocity will be zero. Right? And after that, the particle will go in the downward direction, and ultimately after some time it will reach to the ground again. From the point of projection up to the last point where it reaches the ground again, that horizontal distance is called range. Range of the projectile motion. Okay, range. That is normally denoted by capital R, range. So here also you can apply those formulae for kinematics, like S is equal to ut plus half at square, V is equal to u plus at, V square is equal to u square plus 2at, where a is acceleration, small t is time, u is initial velocity, v is final velocity, and s, this is displacement. Everything is known to you. So, say time taken, the total time of flight is small t. Total time of flight is small t. Right? So, if you want to use the formula, v is equal to u plus at. So, at the peak point, the final velocity, the upward component of the velocity becomes 0. So if you want to use this formula, v is equal to u plus at, then in the left hand side, instead of v, you write 0. Final velocity is 0. Initial velocity is how much? The vertical component of the velocity is u sine theta. So write instead of u sine theta in the right hand side. Then plus at was there. So instead of plus a, you write minus g. Downward direction. That's why minus. Into t minus g. So, what is the resulting equation? 0 is equal to u sine theta minus gt. So, t is equal to how much? T is equal to u sine theta by g. This t is not the total time of flight. This is the time required to reach to the peak point, the maximum height. This time is that much. T is equal to u sine theta by g. So, time required to reach to the maximum height is equal to u sine theta by g, where theta is the angle of projection. Okay? Next, we want to use the other formula, s is equal to ut plus half at square, where s is the displacement. Now, when the particle was at the ground level, in that case, the displacement was how much? It was 0. Ultimately, the particle reaches to the ground again. What is the displacement? That's 0. What is the net displacement? It is again 0. Net displacement along which direction? Net displacement along vertical direction. Net displacement along vertical direction is 0. Right? So now use the formula S is equal to ut plus half at square. So instead of S in the left hand side, you write again 0. 0 displacement. In the right hand side, ut is there. So u will be replaced by u sine theta. Multiplied by t. This t is total time of flight. This t is total time of flight. Okay. So u sine theta into t plus half at square was there. So a will be replaced by what? It will be replaced by minus z. So minus half zt square. Resulting equation is what? 0 is equal to u sine theta t minus half gt square. So this is the quadratic equation in t, and if you solve this, you will get t is equal to 0 and t is equal to 2u sine theta by g. 2u sine theta by g. So t has got two answers and both are correct. T is 0 when? Because we have used displacement to be 0. Initially the displacement was 0, and in that case time taken for the particle for displacement, for 0 displacement was 0. Okay? So t is equal to 0, this answer is also valid. And the next answer is 2u sine theta by g. That is the time required for the maximum flight. Means when the particle again reaches to the ground. That is the total time, 2u sine theta by g. So what is the range? Range is equal to the horizontal component that was constant. Okay, that was constant velocity. So say so what will be the distance? Means range will be equal to that constant velocity multiplied by the total time. So constant velocity is how much? It is u cos theta multiplied by total time, and total time is nothing but 2u sine theta by g. So u cos theta into 2u sine theta by g. That is the range. U cos theta into 2u sine theta. So it is u square sine 2 theta by g. Range is u square sine 2 theta by g. Sine 2 theta why? Because 2 sine theta cos theta is there, and you know that sine 2 theta is equal to 2 sine theta cos theta. So that is the range r. So now range r is known. Time required to reach to the maximum height, that is also known. What else you want to know for this problem? The maximum height attained by the particle, right? That is still unknown. Maximum height attained by the particle. So height means displacement here. Okay. So for displacement, the equation known is s is equal to ut plus half a t square. So in that equation, instead of that t, you know that time required to reach to the maximum height, it is 2u sine theta by g. U sine theta by g. U sine theta by g, that is the time. So in that equation, s that which appears in the left hand side, you replace s by h, that is the maximum height, small h. Okay. Ut, u is u sine theta, t is u sine theta by g, right? U sine theta into u sine theta by g, and half a t square plus half a t square, that will be replaced by minus half gt square. So minus half g into t square is how much? It is u square sine square theta by g. So minus half u square sine square theta by g, and in the first position is u square sine square theta by g. So result is half u square sine square theta by g, or u square sine square theta by 2g. That is the maximum height. Both is not required for such problems, blackboard or whiteboard. For such problems at BTech first year level, boards are not required. Only verbal communication regarding such problems are sufficient, I think. Anyway, later I will show you using both the same thing. You just try to keep in your mind the technique of analysis. If you become habituated in making analysis of your own, then you can solve most of the problems of engineering mechanics or classical mechanics. You have to make your analysis of your own. Choice is yours. Whether you want to make your own analysis or you want to get all the analysis from some source. That is your choice. But I'll suggest you, try to solve few of the problems, at least 20% problems from the exercise of the books which are consulted by you. Different students consult different books. Whatever book you have with you, at least 20% of the problems given in the exercise should be solved by you. If you are able to solve, then you can say that you have learned something in this field of mechanics, classical mechanics or engineering mechanics. Anyway, this is the end of this topic. Thank you. Have a nice day.